in this video, we're going to build an e-commerce platform powered by Medusa. Now, Medusa is an open source commerce platform that has a built-in engine or a framework for customization. Now, it's open source, meaning that it's an open source library. You can download it, host it locally, or host it for your own, or you can use the hosted version of Medusa, which we're going to get into at the end. It is a platform, meaning that it gives you a backend server and admin dashboard that you can use to manage your store data, your products, your orders, and whatnot. We're going to walk through the setup, and you're going to see this in action. And the last part is that it also comes with a built-in engine or a framework in version 2 that allows you to extend the data models and customize the features or this commerce modules to whatever business logic that you want, which is an exciting part of this library that we're going to talk about today. So let me just change this screen so I have more space here so we can dive into the documentation and see how this is going to work. We're going to build an application together, a backend server, an admin dashboard, and also a NextJS frontend or a storefront that connects and communicates with our backend API together. And then through this setup, we're going to learn about different features that Medusa provides. Now, before we dive into the setup, I just want to mention the new architecture in version 2, which is decoupled modules. This is going to allow you for greater flexibility and customizability, meaning that each module or the logics inside of your commerce backend is now isolated into separated modules. Let me show you what I mean by this. Now, down here, you can see we have different modules. For example, in the category of cart and purchases, we have a cart module. We have customer modules, payment module. We have products, pricing, regions, order management. Now, all of the functionality that Medusa provides is provided through this isolated, independent modules that you can use in different parts of your application. You can even replace them with your own custom module. So it's interchangeable with your own custom module that allows you to extend the functionality. And the Medusa backend or the server is going to orchestrate all of these modules together, giving you that functionality that you need for your commerce. Now, I think that's a very cool feature that makes Medusa a flexible and extendable commerce provider. Now, with that, let's just go to our documentation. There's going to be a Medusa version 2 documentation specifically guiding you through the features inside version 2. Now, right now, the version 2 is in release candidate. You're going to have to pass in this release candidate at the end of your Medusa. By the time this video is launched, the version 2 is also launched, and you can just run at latest. Now, I have a little note here for myself too, just summarizing what we're going to be going through here from a high level. So before setting up, let me just go through the notes here. As I mentioned, Medusa is an open source commerce platform with a built-in framework for customization. We're going to see this in action where we talk about different modules and different functionality in Medusa, and you would have a better understanding by the end of this tutorial. Now, it provides essential building blocks to create a powerful commerce store that fits any business. So you would have the essential building blocks of any commerce application, such as product, cart, ordering, and stuff, but you can also extend and create your own modules that is going to be plugged inside of this synchronized or orchestrated backend system. Now, these building blocks are mainly two-part or two different categories. One is the commerce modules. As I have shown you, there are different modules such as products, orders, and carts that help you build your commerce functionality. And there's also a core package, which is responsible for orchestrating these different modules together and also allows you to extend models, create new tables, create links between different tables, expose API endpoints to then expose this functionality to third-party applications, to your storefront, to your admin dashboard. So the core package is the server or the built-in engine that we talked about that allows you to actually deliver this customization. Now, the core package is a server, has two main objectives. First is to orchestrate the custom commerce modules or the commerce modules that comes built in with Medusa, and also to expose a REST API endpoints. Now, API endpoints is the main way that you're going to expose functionality to any service that wants to use your commerce backend, whether it be an app, a storefront, or your admin dashboard. So this is another feature of our server backend that exposes this API endpoints. Now, the core package also holds the logic that allows developers to extend and add custom API routes along with other available customizations. We're going to see this again more in action. What can you build with Medusa? Well, you can build any e-commerce experience store. You can build a marketplace where sellers and buyers can come and meet each other, something like Amazon. Subscription businesses. So this has a built-in module. You can extend it to whatever logic that you want. Order management system, B2B store, point of sale, or POS. So there are different things that you can build with Medusa. Really, the sky is the ceiling. In terms of the setup, we can go back to the documentation that we have. We're going to prepare our environment, which we need a Node.js version 20 plus for version 2. You need Git for your version control, and then we need Postgres because Medusa is going to use PostgreSQL to store data for your commerce system. So you need to have either a local Postgres database or a hosted version that Medusa can use during your setup. Now, there's a link here in the description to the Postgres website. Depending on your local machine, you can use macOS or Windows to install a local Postgres version. I've already gone ahead and selected Windows. My machine is the Windows. I've selected the Windows and installed a local Postgres. During the installation, you can select a password that Medusa is going to also ask you the first time that you install it to be able to connect to your Postgres. So once you have done that, you're able to actually go ahead with the installation command. And then from this point on, we're going to install the backend, the admin dashboard, and optionally an NextJs storefront. And then we're going to walk through an A to Z of a product order and what you get in the admin dashboard. And then we're going to talk about the architecture and the file system, different folders and different functionalities that comes with Medusa. So let's go back inside of the documentation in here. So we opened up this part. Let me close that part and also close this one. So to get started, we prepared our environment. Now we're going to run this create Medusa app at RC. So I'm going to copy this command inside of a Medusa folder that I've already created. Now this is going to ask you a couple of questions in how you want to set up your Medusa application. The first thing is, what is the name? I'm going to give it a name of commerce. It asks you whether or not you want to also install the Next.js storefront. Again, we're installing the server. It comes with an admin dashboard, but you can optionally also have a Next.js front end or storefront that connects to your backend. So I'm going to select yes to also see that. It is asking me for Postgres username, to say Postgres, and then give it a password. I'm going to type in enter the database name, can be anything here, Postgres. I've already installed this application before with that name, so it is asking me for a new name. Okay. Now, this is going to take a while to install the backend, the server, the admin dashboard, and also the Next.js storefront. So I'm going to pause the video, wait for this to finish, and then I'll be back. Okay, this should be done in any moment. Once this actually goes through and finishes, it automatically redirects you and opens up a browser page for you to create your admin user. So it opens up the admin dashboard and allows you to also create a user to be able to connect to your backend server. So let's see this in action now. Okay, so we're going to create a test user, admin at Medusa.test.com. Give it a name, a password, and then create an account. We can start a Medusa admin with the same user that we just created. And now you are logged into your admin dashboard. As you can see here, it has been seeded with some sample products and a page for referencing our orders. We're going to go through an order and actually see this in here. Inventories, customers, promotions, and price lists that you can define. There are different settings you can have for your store, from name, regions, tax configurations, sales channels, and whatnot. There's going to be different user guides that I'm going to link in the description below or inside the documentation on Medusa website for how to use your admin dashboard or how you can use these different settings. We're not going to talk about those in this video, but we're going to have links in the description or future videos that we're going to walk you through different things that you can do inside your admin dashboard. So let's go back inside of our application now. After running this script command, if you look at the left-hand side, it has created a commerce. That's what I named my backend, commerce, and also the commerce storefront, which is going to be my Next.js application. Now, let's also run the Next.js application so we see our storefront as well. So here, I'm going to just go to the commerce storefront. Now here I can run npm run dev. This is a Next.js app. We're going to look at the file structure in a second now. Okay, it seems like this process that we are running here, it's already starting our Next.js storefront as well. So let me just go into our commerce backend here. So this is the commerce backend. I'm going to npm run dev here. This is going to run our admin dashboard on localhost port 9000 and /app. That's where you can actually access your admin dashboard as we were doing it here up on the app on 9000. But now that we have this running in a separate process, maybe I can clear this out and npm run dev. This is going to separately run the storefront, which is a Next.js app on localhost 8000, which is going to communicate to our backend via API routes or API calls. So let's see this in action as well. And then we're going to jump into the code and I'm going to show you the Next.js front end from a high level. Then we're going to jump inside of our own backend and then talk about the file structure and different functionality that comes inside your Medusa server. And then we're going to continue in the docs there. So this is our Medusa store front end. I'm going to make it a bit smaller so you can see it from a high level. Let me make this big again so you can go to the menu in the store. As I mentioned, your database has been seeded with some sample products, as you can see here. So you can go on a specific product, for example, to see different images. It comes with a beautiful and minimal design for your storefront. You can customize it to your needs. You can even connect it to your own storefront. It doesn't need to be Next.js. It can be any storefront for that matter. It's at the end of the day talking to your backend via API, so you can just have whatever storefront or framework that you like to build your storefront with. So let's go through an order here. So I'm going to select the size, add this to cart. It has this nice cart module that pops up when you hover over the cart. You can go to your cart. Let me make this a bit smaller so you have your product selected. You can proceed to checkout. From here, you can put in your information and complete a checkout. Let's just give it a name, an address, a postal code, city, maybe Copenhagen, Denmark. I'm not familiar with provinces in Denmark, so email, let's go hamed@test.com. And let's continue to delivery. We can define different deliveries inside of our backend. For now, I'm just going to pick the standard shipping. For payments, for testing purposes, we're going to just go ahead with this manual payment. There is plugins in Medusa that works already with Stripe and PayPal. So you can just define that as the config inside of your Medusa config to then enable Stripe as your payment if that's what you want. So we're going to just use the manual payment for development review, and then we place the order. This is going to redirect us to a thank you page that shows a success inside of our order. Then we're going to see or go to the backend and see this. So this is the thank you page. The order was placed successfully with the delivery and payment information. Now, if I go back to my backend or admin dashboard, if I go to orders, here we go. So the details of the order, the product, the payment, who the customer is. I'm going to make this a bit smaller so you can see what's going on from a high level. It has a very nice backend design, and this is one of the things that has been improved inside the version 2. It's a nicer backend. They have their own UI packages. I'm going to mention it when we go in a few minutes further on into actually extending your admin dashboard. Now, as you can see, it comes with some pages and widgets that you have here, but you can extend your admin dashboard as well. You can add pages to it. You can add different widgets to this different pages. We're going to do this together, and you can use the Medusa UI package to have a similar design as what they have here, which is inspired by ShatCN, and it is using Radix UI under the hood. So you get accessibility out of the box with this UI package, which is great. Now, let's go back inside of our code and actually look at the projects from a high level. Let's just start from the storefront. As I mentioned, this is a NextJS app. If you've been following me on the channel, you're probably familiar with NextJS, but again, this is optional. You can build your storefront with any framework that you want. Your code is mainly inside the source. Your pages are defined inside of the app router. The country code is because Medusa supports different regions, so you can have different regions, different countries, and it automatically picks up or can redirect the user to the correct region in terms of the shipping or whether or not a specific product is available, different warehouses that you can define, different tax settings that you can set. So I'm going to leave this to you to explore more for different features that Medusa provides. But these are mainly your different pages inside of your Next.js app. You're going to have a library folder for context and hooks that works with your data. Modules is all of your components that are working inside of your pages, working with your backend and the APIs inside of your Medusa backend. You have your styles, global styles, and a middleware that's basically getting the region and redirecting the user to a specific region if needs be. This is a Next.js middleware. If you're not familiar with Next.js middleware, there's videos on the channel where I talk about the middleware, specifically working with different locales. In this case, it's not a locale, it's country code, but it works the same way where we get the region from our settings and redirect the user from there. So again, from a high level, this is a pretty standard Next.js app with the design that you just saw and some components that you can just go ahead and customize for yourself, whether it is creating new pages or customizing the components that it's already here. You can just build on top of this storefront to accommodate any need or any design that you have inside of your app. Now, this was the commerce storefront. Let's go to the commerce backend or the server side of our Medusa application. Again, everything lives inside of your source. The admin is going to expose any custom functionality that you would want to add to your admin dashboard. The APIs is for your API endpoints. Medusa comes with admin and store APIs automatically or out of the box, but you can extend and add different or more API endpoints to expose new functionality to your storefront, to your admin dashboard, or to any third-party service for that matter. So this is how you would expose new API endpoints. We're going to do this together, so don't worry if it doesn't make sense right now. Jobs is to define scheduled jobs or cron jobs that is going to run on in specific intervals, and it has access to your commerce modules or to your backend, to your data, so you can just do any scheduled tasks there. You can provide links between different data tables so that you can extend or build on top of Medusa's application or data models, which is pretty powerful. I'm going to mention how this works. Now, modules is the building blocks of Medusa and how you actually add customization. So anytime you want to extend models or extend functionalities, you would create a module. You can create models or data tables inside of your database. You can export services that works with data tables, and then expose this module through this Medusa container to the rest of your app. That is just the synchronization engine between all the modules. Again, this is a little abstract right now. We're going to jump into the example and see this in action. Scripts is any function or any script that you want to load. Subscribers. Medusa works with events, so anytime an action is happening inside of your application, such as the admin creating a product, events are emitted, and then you can define subscriber functions that run once this specific events are running. We're going to see the examples for this as well. And workflows is a series of steps. So imagine that you want to run a task that is a series of actions and queries. Now you would define that inside of a workflow, which is basically a combination of multiple steps. And what this gives you is the ability to, first of all, track the progress of this workflow. Secondly, it enables you to run a rollback function. So if any error happens, you can roll back this step to make sure that your data is consistent. And thirdly, it automatically retries the failed steps. So it's a more robust way of completing tasks, specifically when they're multi-steps and when they're talking to third-party services. So you don't want your data to be inconsistent between different services if any error occurs. So this is from a high level how you would extend your Medusa application. The one file that I want to also mention is Medusa config. This is where you would define different config for your project, such as your database URL and whatnot. We're going to use this to also define some modules in a little bit. So with that, let's actually go to our documentation and do this. So we have set up our Medusa application. And now the first thing that I want to do, or what I want to cover here really, is this basic concepts in Medusa that is going to introduce all the customization or flexibility that Medusa has in these basic concepts. And then you can build whatever functionality that you want using this knowledge on your own. So let's just start from the project convention. We talked about the different folders that already exist in the source folder, from the admin, API, jobs, modules, all the way to workflows and the Medusa config, which is where you would just set up your configurations. Let's just start from Medusa container. Now, Medusa container is a concept that is going to allow you to use different services and modules inside of Medusa. So it holds resources registered in the Medusa application, such as different services. Now you're going to use this container to resolve the services. For example, we have an API endpoint here. It is defined with this get, so it's a get API endpoint. And inside of it, I'm receiving this rec.scope, which is that Medusa container. I'm going to use the resolve method on it and resolve the product module. So remember that this different functionality in Medusa comes in the form of independent isolated modules, such as product module, cart module, or your own custom modules. And they're all registered inside of this container. And you can use the container to resolve this service and then use that service. For example, here inside of an API endpoint, you can use it inside of a workflow. You can use it inside of your scheduled tasks, for example. So that's how you're going to, this is the engine that actually synchronizes your services and different modules. For example, here we're getting the product module service. And from here, we're calling the list and count products to get a count of all the products that we have inside of our backend. Okay, so just to test this out, we can create this API endpoint. So inside of our sources, we can go to the API, and I'm going to create a new route called count. Inside of it, I'm going to create a route.ts. We're going to have a specific section for creating API endpoints. So I'm jumping a bit ahead, but I want to show you how we're using this Medusa container that lives inside of this request.scope to resolve the product module, get the count, and then respond back. So let's save this out. Once you save this route inside of your API, this is how you create your backend server-side API endpoints. If I open up Postman route now and go ahead and hit our API endpoint count, this is going to give me the count or the total number of products I have right now. So just as easy as that, I created an API endpoint. I used the container to resolve to my product module. This was a module that comes built in from Medusa, and I got all the counts of my products, exposed this functionality through an API endpoint, a GET request to the outside world. Now, this can be my storefront, this can be my admin dashboard, or a third-party service. You get the idea. Now, let's talk about modules. Now, modules is a combination or a package of reusable functionality. So you're going to package this functionality inside of a module. Now, it can handle business logic in a class called services. So when you create a module, you also export a service that actually is the functionality or the business logic for this module. It typically defines and manages data models and represents a table in the database. As I mentioned, Medusa comes with pre-built modules for your core commerce, such as a product, cart, shipping, and whatnot, but you can also have your own custom modules or extend the modules that Medusa comes with. Now, how to create a module? Well, you can go inside the sources folder, inside the modules directory, and create a module. For example, hello here. We're going to define a data model, which represents how the table inside of our database is going to look for this data model. So this is the schema for a data model. If you're using the model.define, give it a name for this specific module. So let's go to our modules. We just close everything. I'm going to go to source. I'm going to go to modules. Here I'm going to define a new module called hello. Okay. Now, the first step is to create a data model inside of a models folder. So that's what we're going to do. We're going to create a models folder, and inside of it, we can create a custom model. Let's say we name it custom.ts, and we're going to paste in this code. So let's just get this, name it custom. That's what I named my model. So to this model.define, you pass in two parameters. The first one is the name of the table. It needs to be snake case in your Postgres database. And the second one is the schema or the shape of records inside of this table. So each one has an ID. You're going to use the model function to define these keys, and then a name that's a text. I named this model custom, and then I'm going to use this to expose some services to the outside, to other parts of my application, which is the next step. So create a service. Now, a module must define a service that implements its functionalities, such as managing the records of your custom data inside of your database. So you're going to have to create a file called service.ts. Then I copy this. And then here, we're going to define a service. Now, I named this custom, so let's rename it to custom. Now, we're going to extend the class that's created out of this factory function. So Medusa service, it's going to receive a custom module. So we created this a custom data model that we just created in the last step. We named it custom. That's our custom data model. We're going to pass this custom data model to this function. This is going to create a class that has methods for updating, creating, reading, or the CRUD operation on this data model inside of our database. So instead of having to recreate or reinvent a wheel for every custom model that you create, you can just extend this Medusa service that automatically creates this CRUD operation methods for you on this class that you're going to register inside of your Medusa container and expose it to the rest of your app. So that's creating the service. Now that we have the service, we need to actually export this module definition. So we're going to have an index file here, .ts, where we're going to define or export this module with the hello module name and actually a service that's pointing to the service we just created in the last step. So we're saying, hey, Medusa, if we want to use this custom service that I created, the service lives here. You can expose this module and the services, the functionalities with the rest of my app. So we can use the Medusa container to then access to this specific service as well. So let's say from a high level here, we created this hello. Inside of it, there's this index that exports the module. There's a service that creates the service by extending Medusa service. And then there was this models folder where we define a custom data model or a table inside of our database that holds the functionality of this specific module. That's how you create a custom module and expose its services to the rest of your application, and one of the ways that you can customize or extend Medusa. Now, the last step to also register this inside of your container is to actually pass this point, the path where this module lives, to your Medusa config. So let's go. Inside of our Medusa config, we have this project config. I'm going to also have some modules. This is going to be an array of different modules, which is an object with a resolve property pointing to where this module lives. So it's in the source, modules, and hello. That's where we created it, source, modules, and hello. Now this is registered inside of our Medusa container and we can use it. But before we are able to use it, through this module, we have created a new data table. So we have to run migrations to actually create these migration files and then actually migrate our database to create this new table with the schema that we defined. So we're going to have to run this service. So let's open up our terminal, stop the dev server, clear this out, and actually run npx medusa db generate for that hello module service. So it's going to run or generate the migrations necessary for this specific module that we created, which is going to create a migrations folder inside of our module. So hello now has this migrations. Now, if you look at the migrations, it's basically a SQL script to create a new table and drop if it exists before. So we have the necessary migrations now. And in the next step, we can just run this migration to apply the changes to our database. So we're going to open up our terminal again and actually run the migrate. Now this runs the migration for all of our modules. Now for the modules that we have not created any updates, it's skipped because it is up to date. But for the hello module service, we have run the new migration and completed successfully, which means our database now has a table corresponding to this custom data model that we created, or the hello module. Okay. Now let's test this out. Since we now have registered this inside of our Medusa container, we can access it inside of our API endpoint to get a hold of our hello module and maybe use the hello module services that we extended from Medusa services to create a new record inside of our database. Now, this is a function that's automatically created on our service because we extended Medusa services, and it just created this CRUD operation for us, creating, updating, deleting, and whatnot. And we're going to generate a new record or a new row inside of our table and return that. So let's create this API endpoint. Actually, we're going to have inside of our API, we're going to create maybe a new route that says hello. Inside of it, I'm going to say route.ts, and I'm going to copy this command here. Let's just close the terminal so we have enough space. Now, this CRUD operations or CRUD functions are mapped to your model. Because I named mine custom, it's create customs with a plural. This is mapping to whatever name that you have put on your model. So create customs, it's going to just create a custom or an instance of the custom data model inside of our table with a name of test. Now, just note that I have created an API endpoint. This is how you create API endpoints. You export functions that map to an HTTP verb like get here. I'm receiving the request, Medusa request and response. Just is like an express endpoint or a middleware that receives a GET request. It has an instance of the request and response and some functionality on this instances. For example, on the request.scope, we have the container. We're going to resolve our hello module. On the hello module service, we can call the create customs to create a new record and then send it back. Okay, so with this endpoint, if I now go to my Postman and hit the hello endpoint we just created, resend this. Okay, here we go. So it created a new record, gave it an ID. Something that I forgot to mention when we were defining our custom data model is that by default, it also has a created ad, updated ad, and a deleted ad property, and that's what you're seeing here. So the name was test that we passed, the ID, the created ad, and updated ad fields were automatically also populated. So we defined a new module. This module had a custom data model or a table. We exposed some services that operates CRUD operation on that data model or table. We then registered it with Medusa container, run the migrations, and then use the service inside the Medusa container in an API endpoint that we defined here to then just create a new sample or instance of this module inside of our database. Okay, so that's completing the test. Now, why would you use modules? In commerce, you often need to introduce custom behavior specific to your products, to your industry, to your tech stack, or general ways of working. In other commerce platforms, introducing custom business logic and data models requires setting up separate applications to manage these customizations. Medusa removes this overhead by allowing you to easily create and write custom models that integrate with the Medusa application without any implications on the existing setup of Medusa. So when would you want to use modules? Whenever you want to create a new table to your database, whenever you want to extend the existing tables in Medusa, when you want to integrate with a third-party system or any feature, or if you wanted to reuse your custom commerce features across Medusa applications, you can just define these modules that it allows you to even use them inside other environments such as Edge functions or your Next.js app. Now, we've briefly touched on API routes. API routes is how you would expose different features of your commerce to external applications such as your storefront, admin dashboard, or third-party systems. Now, Medusa's core application provides the store and admin APIs out of the box. If you go to the API, you can see this admin and also the store. This is what comes built in, or the necessary APIs, functionality that your commerce application needs out of the box, but you can also create your custom API routes and expose your own custom functionalities, which we have tried a couple of times. At this point, you will create a route.ts or route.js inside of the API in the source directory. You would then export route handler functions that map to HTTP methods such as get, post, delete. And then from there, you just export the functionality or just the logic that you want. In this instance, we're just returning a JSON object with this message property. You can just test it out by running curl, or in our case, we're just using Postman to send a request to your backend, which is living at localhost port 9000, and then hello world. Now, one thing to note is that even though we are creating this API endpoint inside the API folder, the endpoint doesn't have the API path in your path. So whatever you put inside the API, it just turns into an API endpoint with the path or the directory that you have defined, and the actual API is not part of the path. Just something to note. Now, when do you want to use API routes? When anytime that you want to expose custom functionality to be used by the consumers of your backend, it being your storefront, admin dashboard, or external applications, you would use the API endpoints. Now, as we mentioned, Medusa comes with built-in commerce modules for a list of all the modules that's already inside of your Medusa applications, such as cart, customers, inventory, payments, products, regions, taxes, and whatnot. You could just reference the documentation. The way that you would resolve the commerce module services is through the Medusa container that we've already talked about. For example, inside of your API endpoints, you get access to the container on this request.scope. You can then resolve to any of this commerce modules that comes built into Medusa to then get the functionality that they provide, such as this list and count that gives you a count of all of the products. Now for the directory structure of a specific module, we have already seen this in action together. So we had the index, which was exporting the module. We had the service, which defines the functionality that works with the data models of this specific module. We had the models folder where it defined a custom model. That was the schema of our database. The migrations was automatically generated when we ran the migration command for Medusa to then actually generate some migration scripts for us to be able to create this new database. And we have something that calls loaders, which we're going to talk about next. This is functions that just run one time at the startup, at the application startup. And that's how you would define a module. Okay, so let's go to loaders and see what loaders are. Well, loaders are just functions that are executed at the application start. So if you want to run anything once when your Medusa backend starts, you could put it inside of a loader. This can be scoped to a specific module, so you can just organize the loaders or scripts that you want to run at startup. For example, if you wanted to sync your data between Medusa and a third-party service, and you want to run this once when the Medusa starts, you could put it inside of a loader. How do you create a loader? Well, you would just create a loaders folder and a TS file inside of it that just exports a function that runs when the application starts. Once you define that, you're going to bring this loader to your module definition and specify that your module actually has a loader. So loaders are, again, scoped to your module, so you define the specific loader for your module. Okay, so let's actually do this together. So we're going to go to our hello module, create a loaders function, and then a loader. So let's go inside. Let me close the API, go to the module hello. I'm going to create a new folder called loaders, and inside of this, let's just put in a hello.ts, and I'm going to copy this code. It's just going to log this into the console. Now that I have this, I have to go back to my module definition, which is inside of my index, and I have to say, hey, the service for this module was that, and the loaders is this guy. So I have to bring the hello world loader. So hello, there you have it. So that's imported from my loaders. Now, if I save this and open up the terminal, we should be able to see this hello. If you look at here where I highlighted it, it's just hello module just started the Medusa application. So this function that we defined inside of our loader just ran at the start of our application. Okay, so we tested it out. Now, when would you want to use loaders? Again, when you're performing an action at application start. And this is a one-time, it's not something that reruns, it just runs once. So for example, if you want to establish a one-time connection with an external system, if you want to sync your data with an external system, you can just run this. Now, if you need something to run continuously or at a set time, you can use scheduled jobs, which we're going to cover later on, which is like scheduled cron jobs that run on specific intervals if this is something that needs to rerun. Now, the next thing that comes out of your Medusa backend is events and subscribers. We touched on this briefly. Medusa emits events when different things happen inside your Medusa backend. For example, if you create a new product, it emits a product.created event. You can subscribe to this event and run functions in response to this event to synchronize it. Maybe let's say you have a CMS, a content management system, and you have your Medusa backend. Anytime that you're creating a new product in your Medusa, you want to also send some data to your CMS, so you don't have to manually sync this. It automatically responds to this and sends maybe a webhook to your CMS to just import this or create this product inside of your CMS as well. Something as an example. So again, events, actions performed inside of Medusa, they're going to emit these events, and you can just subscribe to them. How are you going to create them? Well, you can go to your subscribers directory, create a TS file, export a handler function, and a config that says run this handler when that event is happening. So product.created. Okay, so let's just copy this. Or maybe we're going to test it with the more extensive example that we have down there. So bear with me for a second. So we need a handler and a config. That's all. This is what runs when that event is triggered. The config is also defining the event that the subscriber is listening to. Here is product.created. Now to test it out, you can just go ahead and create a new product. We're going to do this in a second. And in response to that, you can just run that a product was created. We're going to extend this by actually using other services inside of this handler. And this is what I meant by a more extensive example here. Now, inside of this product handler, this subscriber function, you have access to Medusa container on top of the event data. So the event data is the event that was triggered, so product created. So we get the product data, but we also get access to Medusa container, so we can resolve to any other module that we want, any other services that we want. So for example, here, we are resolving the product module. So product module services. We are getting the ID of the product that was just created out of the data that's passed to our event. And then we're going to use the product module service to retrieve the product with this ID. And like, for example, here, we're just logging the product title, but you get the idea. The point I was trying to make is inside of this subscriber handler functions, you have access to Medusa container, which is basically access to all the functionality or the modules custom built in inside of your Medusa backend, which makes them very powerful. Okay, so let's actually create this one. So I'm going to create a subscriber product created. So let's go to our subscribers, create a new file. Let's say product-created.ts. Let's copy the code here, close the terminal for a second. So again, this is the same code that we had there. Anytime that a product is created, this function is going to run, is going to use the container to get a hang of our product module service, use the data that was passed inside of our event from Medusa to retrieve the product and then log the title of it. Okay, so we have this subscriber right now registered. Now all I need to do is to go back to my application, go to my admin dashboard. Let's refresh this. Let's go to our products and actually create a new product. Let's go to products and let's create a new product because the event we defined is product created. So winter jacket. Well, when you're defining the product, you can pass subtitle, you can pass a slug or handle as they call it. This can also be automatically generated if you leave it empty. A description, you can upload images, you can define different variants for this product. For now, I'm just going to continue with a name. As you see, there's different options that you can fill in here, such as the type, category, collections, tags, and whatnot. This is going to enable you to then search or filter based on different categories inside of your admin dashboard or your storefront. You can define different sales channels, so it can be online, it can be in store. So you have this functionality out of the box with Medusa, which is great. And then I'm going to publish this product. So I have this winter jacket product created now. If I go back to my application and in my console, what I should be able to see is these two lines. First of all, the info runs that says processing product.created, which has one subscriber. So we have registered a subscriber that responds to product.created. And then I have the product winter jacket, which is the title that I gave to the product, logged into the console, which is what we were doing inside of this handler function by logging this here. But you get the idea. You can just extend your application through this custom subscribers that respond to different events and synchronize your data inside of from Medusa with external applications, or do anything that's necessary here really to process this task. So let's go back to the docs. Now, for a list of all the events that are emitted in your Medusa backend, there is a reference here. So reference the documentation for the list. And next, we're going to talk about scheduled jobs, which are basically cron jobs running inside of your Medusa server, which is great because not only it gives you a scheduled cron job capability, but it also has access to your Medusa container, which means all of your custom modules or built-in commerce modules inside of your Medusa backend. How do you create scheduled jobs? Where you go to the folder jobs, you create a TS file, you export a function and a config option that says what's the name of this job and what is the cron expression or how often should this run. For example, here, just logging hello, and then we are running it every minute. We're calling it every minute message. Okay, a simple example of running a cron job when your Medusa backend is running. Now you can also extend it. As I said, you have access to your Medusa services. So your cron job or your jobs function has access to this container, which is Medusa container. You can use it again. You get the idea. This is a similar pattern that we've seen in all of the functions that we've seen so far. So we use the container, resolve the module product, and then here we're just using the product module service to get the list and count products function, get the count. Okay, but you get the idea. This can be, synchronizing your products with an external service, maybe running internal tasks every minute. For example, here, as an example, it says if you want to, let's say, synchronize your inventory with an ERP solution or enterprise resource planning solution once a day, you can just set it in your scheduled jobs. This is going to run and sync the two services together, for example. So here, we're just logging our products. Let's actually run this every minute and see how this works to test this out. So inside of our jobs folder, so commerce, source, jobs, I'm going to create a new file called maybe count, because we're counting products. So .ts, inside of it, I'm going to paste this. Let me just close the terminal for a second. So again, it's a custom job running. It's a function that runs every minute because I have defined it inside of this config. It retrieves the product module service, the count of all of my products, and then just logs it into the console. Okay, so let's open up our terminal now, and we should be able to see this logging any minute because this runs every minute. And we should see a log of the total number of counts of our products. We initially started with 4 products. We created one of our own. So I'm assuming that we have now 5 products, and we should see this log at any point here. There we go. Time to check products. You have 5 products. And as I mentioned, this runs every minute. So another minute passes, this can run again. You could set it to run every hour, once a day. You get the idea. This is a regular cron expression that you can pass in here to define how frequently this job needs to run. Now, last thing that it's also a very exciting feature in Medusa, it's the concept of workflows. We touched on this really briefly. It is to complete a series of tasks and queries. So anytime that you're running a multi-step task that has different steps or talks to different external services, to make it more durable, more stable, and error-prone, you would want to run it inside of a workflow, which defines this tasks into different steps so that you can track the progress of each step. You can roll back if they encounter an error for data consistency, and it retries automatically every failed step, which is a great feature that you often find in external services from providers that provide like different workflows, triggers, and queuing services or messaging services for you to define different workflows. This comes built in Medusa, which is great in my opinion. Now, how would you execute a workflow? Well, we will create steps, as I mentioned, using the create step function from the SDK. And then you would define or combine these steps into a workflow. So you would call this create workflow function, and then you would just export a function with these different steps. and then finally return a workflow response, which is going to be the response returned back to whoever executed this workflow. Now, you can execute your workflow from inside an API route, from inside a subscriber function, a scheduled job, any task that you want to perform in your Medusa backend. It's a good idea to do it inside of a workflow because it gives you that data consistency, that rollback functionality, and also it retries the different steps if they fail. So you can make sure that a task is completed correctly when it is actually completed. Now, again, you have access to, this is just showing how you would execute your workflow. So here, we're going to pass our container to our workflow. For example, here, we are calling our workflow from inside of an API endpoint. This can be triggered via a webhook that just then triggers this workflow inside of our application. So you pass it the container, and then you would call the run function on it. Your workflow can expect also inputs, so you can pass any input that you've defined before and pass the input here. Okay. Now, as I mentioned, you can also, inside of each step, access the context object and the Medusa container on it to resolve to any services. So step one here, let's say we are counting the products. Again, we are resolving the product module service and this function on it to get the count. So you have access to your Medusa container, and therefore all of the functionality or custom modules and commerce modules, built-in modules in your Medusa inside of your workflow steps as well, which makes them very powerful. So let's test this together. Let's go up where we're defining these different steps. So we're going to create these different steps. So let's just copy this. I'm going to go to my workflows folder, just close this, workflows. I'm going to create one that says, let's say hello. Okay. I'm going to put an index.ts here. This is where I'm going to define the workflow. I'm going to separate my steps into a folder called steps. Then here I'm going to include an index.js file or .ts file where I'm going to define my steps. Let me close these files. And so we know what we're doing. So let's go. This is where we're defining our steps. So our first step is calling this create step. Just returning a string. You can do anything you want here in this step. Really, you pass it a function, and then you can define any functionality that you need here. Okay. Here it defined a second step as well. So for the second step, our second step actually, this is the function that gets executed when you execute the second step. It requires an input. So it is expecting an object with a name property. Good. Now we want to create our workflow. So we're going to copy this, go back inside of the index that we're exporting from this hello workflow. And here is where I'm going to have my workflows. Okay, so let's get this workflow input. Just for the sake of simplicity, I'm going to copy them both in here. And I'm going to say, my workflow requires this input that I'm going to then pass to second step, because remember our second step was expecting an input. Okay, that's just saying that. Now step 1 and step 2, we need to export these steps because I've put them inside of a different file. I can export them. You can also define them inside the same file. It is just for organization purposes that I put them inside the steps. There's no requirement. You can just define them inside of the workflow file altogether. Now I can import these. Step 1 and step 2. So what's happening here? We are creating a workflow. We are calling it hello world, and we're passing a function that's running anytime anyone executes this workflow. This function needs an input. It runs step 1, get the response, runs step 2, passes the input, gets the response, and then finally returns a workflow response, which is then returned to whoever executes this workflow. So far, so good. Let's go back and let's actually execute our workflow. Now let's imagine that we're executing this workflow from an API route. You can, again, run it from inside of a subscriber, a scheduled job. For simplicity, I'm just going to execute this workflow from inside of an API get API route. So let's go ahead and create an API endpoint called workflow. So inside of our APIs, this is going to create a server API endpoint for us. I'm going to name this workflow. Inside of it, we need a route.ts file. We named this hello, so let's just leave it at hello. Save. Okay, so API endpoint, a GET request. It's executing the my workflow. We are importing from the workflow we just created. We are passing the Medusa container to it. That's how you execute your workflows, and you call the run function on it. Now, because we are expecting an input, I'm passing in an input property into that object. And my input, as I defined it here, is this an object with a name property. So I'm defining it here as well, an object with a name property. And I'm getting this name from the query parameters on the request that came into my endpoint. Okay. And then I'm going to send the result back. Now, this workflow, what does it do? It executes the first step, passes the input to second step, and then returns the response of our first step as a message. So let's just test this out. If I go and open up my Postman now, let's go here and open up Postman on top of it. Okay. So now if I go to my workflow endpoint I just created, see, I get a message back, hello from step 1. That's what I've defined inside of my step 1. Just says hello from step 1. Now let's return inside of our workflow, instead of returning the response from step 1, let's return this the response from step 2. Okay, let's see what happens here. So send again. So hello undefined from step 2. Now step 2, if we look at it, it needs a name to be passed to it. Because we don't have it, it's undefined. Now how do we pass this name to it? Well, inside of our workflow, whatever input you pass to it, when you're executing this workflow, it's passed to our second step. Now, who is executing our workflow? We're inside of our GET request. This is where we're running the run function to execute this workflow. We're passing this input from it, which is coming from our request query parameter. So if I go back and then pass in a query parameter name equals Ahmed, then send the request. It says hello, Ahmed from step 2. Now, this is just to show a simple example, just to show that how powerful the workflows are, in that you can define different steps. You can pass inputs to your workflow, pass the inputs to your different steps, get the response of one step, plug it into the next step, and complete a series of tasks in a way that's trackable, and also you can roll it back if an error happens. Now let me show you how you would define a step with a rollback. Now let's say this first step that we created, the first parameter we pass to it is the name of our step. The second parameter is the function that gets executed whenever we execute this first step, but it doesn't stop here. You can pass in another function, and this function is your compensation function or rollback function. So anytime this step encounters any error, this function is executed. So let's say inside of here, we are creating a new instance of our custom model, of our product, of our brand model that we just created, and something went wrong, and we want to delete that, whatever, or reverse, roll back whatever happened inside of this step. So you export another function from each step. That's your compensation function or rollback function, and you can pass data to this. So whenever you are returning this new response, the first parameter is the response of this step, but you can also pass in a second parameter. Let's say I'm passing in an ID. This is then passed in to your rollback function. So this is going to then expect an ID of type string. It also gets the container inside of the context object. So it can talk to any commerce module, any of your database tables, to reverse whatever happened inside of this step. And that, I think, is very powerful. That comes built into your Medusa workflows. And on top of this, you get the automatic retries anytime that you encounter any errors. And that's workflows. Now, the last thing I want to talk about in this basic concepts in Medusa is actually customizing your admin dashboard. As I mentioned, you can add pages or widgets to your admin dashboard. Widgets are just components that you can add to your current pages. So let's say we want to create a product widget inside of our product pages. You can go to your admin folder. This is anything related to your admin backend or admin dashboard. Inside of the widget, we're going to add a product widget and then export this component, which is going to insert this widget into our product detail page before any other section. So on top of the product widget that we can see together. So let's go inside of our source and admin. We're going to create a widget and rename this to widgets. Then here I'm going to have a file that says product widget.tsx, and let's copy this. So what are we doing here? This is just a React component with some UI elements from Medusa UI, and then a config that says where to insert this specific component. So the zone is product page, detail page, and before, which means before any other section. So this should add this heading to our product detail page. So let's save this, go back to our backend. And if I go to products, so if I open up a new product and refresh this, okay, so let's go back and see what we've done wrong here. Okay, so, okay, my bad. I have defined this widget inside of the API. It's actually inside of the admins, sorry. So let's move this up there. Okay, so let's just look at it from high level. We have this admin, we have this API. Inside of the API, we have the admin as well. This is the admin and the store API endpoints, but that's not where we want to export our widgets. The admin folder is where you would work with your admin backend. So you create a widgets folder here and a component with a zone. Now, if I go back to my app and refresh, this should be shown on top of all the sections. Okay, here. So product widget is now added. This section is the custom widget that we just created that's now living inside of our product detail pages. You can also create UI routes or pages here inside of your admin. So it's very customizable. We're not going to cover that here, but if you follow the documentation here, there's this customization section where it uses all the concepts that we just talked about to create a new module called brand. Now, right now, our product doesn't have a brand field. Let's say in our custom commerce solution, we want to also give every product a brand and then also enable users or your admin users to filter based on this brand. So we're going to create a brand module. Then you're going to create a workflow that actually responds to an API request to create a new brand. You're going to link this brand to your product table. So your products now can have a brand ID set on them. You're going to learn how to query these different links. And then you're going to customize the admin dashboard to add a widget that shows the actual brand on the product detail page, and also have a UI route or a page dedicated for your brands where you can just see different brands or different brands, products belonging to different brands. It also talks about integrating or using the same concept of your custom module to integrate with different services. For example, you can just connect your Medusa backend to your CMS and communicate between the two through your custom module, handle events, schedule tasks, and whatnot, which hopefully we're going to cover in a future video where we dive deeper into an example of customizing or extending your Medusa backend through the same concepts that we reviewed here together. And that's a wrap for this video, folks. We covered a lot of concepts and grounds in Medusa, but from a high level, Medusa is a modular commerce platform with a built-in engine for customization. It exposes all the commerce logic through independent, isolated modules that can be used on their own, plugged into each other, or even changed or replaced with your own custom modules. That backend framework or the customization engine allows you to define different models and modules, different tables, link them with current commerce modules, and expose them through API endpoints to your storefront, to your admin backend, and to external services, which makes Medusa very extendable and customizable, which is a great feature for any commerce provider. Because oftentimes when you are building commerce applications, you want to have specific business logic that applies to a specific industry, and instead of having to fight against the platform that you're using, if you can just build on top of it, extend it, it is going to reduce your development time drastically and make it easier to apply this or fit this solution to any business logic or domain out there. Now, before we wrap this, I want to also talk about deployment really quickly here. Our Medusa application is consisting of two parts. One is our Medusa application or backend, which is our server and admin dashboard, which are tied together into one application. They can be deployed separately or they can be deployed as one service to any runtime that runs Node.js, because at the end of the day, this is a Node.js server running. And then you have one or more of your storefronts connecting to this backend through the APIs. Now, for the Medusa application or your backend, you can deploy to any hosting provider that has Node.js. It also has to support Postgres database and Redis. These are the services that Medusa uses internally to store your data. So platforms like DigitalOcean, Railway, or AWS have this. Another option is Medusa Cloud, which is a hosted service for Medusa applications that's tailored toward Medusa. You can sign up on the site to get access to Medusa Cloud if you want to have an end-to-end hosting service that supports your Medusa backend. And as I mentioned, your storefront is just going to be any application or framework that you choose. In our case was a Next.js. You can deploy it to Vercel, for example, as a provider for Next.js. That's as far as deployment goes. I wanted to mention this. We didn't deploy this here. Maybe we have future videos that we talk about deployment, customizations, and other different logics that we can implement inside of our Medusa application. If you have any questions, like always, hit me up in the comments. There's going to be a link in the descriptions for documentations and references that I use inside of this video. And I'll see you in the next one. Bye-bye.